Hello, let's talk about confidence intervals and try to make sure that you understand how it's created and what parts are involved and some of the terminology about it. So confidence intervals that we're building in Master 43 class are built for two specific parameters, which is population proportion, P, and population mean, mu. So they build a little bit different because they're about different values and they come from different distributions, but overall idea of the confidence interval is the same. Confidence intervals are made out of a point estimate plus minus margin of error. Point estimate comes from your sample. Margin of error creates a little bit wider interval because your point estimate by itself cannot accurately estimate your proportion or your mean, but margin of error gives a little more room, a little more accuracy around point estimate, thus creating more confidence in actual estimation of the unknown parameter. Margin of error is always made out of number of standard errors. So this is your general look of your confidence interval. Now let's talk more specifics. In terms of proportion, change the color here. Point estimate would be your p hat. Number of standard errors would be expressed by z-score as number of times, and standard error is the standard deviation of the sampling distribution. That's what standard error is, which is a p hat 1 minus p hat divided by n. So this right here represents standard error, and that's sigma of p hat. This tells you how far you're going to go to create a certain level confidence interval, and this tells you what is used as a starting point of your confidence interval. All of this together right here, plus minus this whole expression, is the margin of error. When we talk about averages, it's the same idea. Your point estimate is x bar, and then number of is represented with t-scores. Standard errors is s divided by square root of n. So again, this right here is a standard error, which is a sigma of x bar. This right here, how far you're going to go to create the interval based on your level of confidence. And this is the center of your interval, which is the value the closest to the mean. All of this after the plus minus symbol is what we call margin of error of the interval or of your estimation. So you always estimate your interval based on your point estimate, but then with a little more room around it, it creates more accuracy as estimation. Both of these ideas are based on grabbing, if you have a population and you sample it and you get your point estimate, that point estimate would be fairly close to what you're trying to estimate as a parameter. And if you look at lots of different samples, Lots of different samples will give you different point estimates. All of these point estimates create unique sampling distribution of that point estimate. So in this case, get my pointer, in this case we're using p-hat distribution. In this case we're using x-bar distribution, which means that every time you look at this curve made out of these point estimates, you'll have a slightly different curve. P-hat distribution or x-bar distribution. They have different rules and different requirements for having a normal shape. And all of that comes from Chapter 8. So some of this information, this standard error and this standard error, also comes from Chapter 8. I hope that helps you to understand what is what in your equation, and I will try to make another video to go into a little bit deeper kind of meaning of why we're doing what we're doing.